In the previous video, we looked at how we can relate the number of atoms of an element to the mass of that element that we can measure out on a balance. In this video, we're going to extend that to discuss molecules. So we're going to talk about specifically what we're going to call molecular mass. Now, incidentally, this term molecular mass is also sometimes referred to as being molecular weight. Sometimes you'll see it referred to as formula weight if you're talking about ionic compounds. And for our purposes here today, in this video, we're just going to kind of use these all interchangeably, just for the purpose of, well, not getting into that discussion right now. So, what is molecular mass? Well, essentially, it's the molar mass for a molecule. Okay? So consider a molecule like water. Okay, we want to be able to determine how many molecules of water are in a given mass of water. But the problem is we only know how to do that with atoms. So we need to have a molar mass for the water. In fact, sometimes I'll just refer to molecular mass as the molar mass. But the water is composed of two elements. We have hydrogen and we have oxygen. Okay, we have two hydrogen atoms and one oxygen atom. Now, if we look on the periodic table, we'll find that the molar mass of hydrogen is 1.008 grams per mole. And if we look at oxygen, we see that it's 16.00 grams per mole. Okay, so for hydrogen, the total contribution is going to be equal to 2 times 1.008, which is 2.016 grams per mole. And then 1 times 16 is going to be 16, so that's our contribution from oxygen. We add these together, and we get 18.02, and that's grams per mole. Okay, that is our molar mass essentially for water. And I'll use that same symbol that I used before, that curly M. Okay, now that we have this information, we know the mass per mole, then we can kind of go back to what we were doing earlier on with just the atoms of elements, and we can create another flowchart, okay, where we have moles of a compound that we can interconvert with the mass of a compound. And just like before, we can do that conversion using the molar mass of that substance. Okay, now we can also go to molecules of the compound. Because remember, mole is just a number that describes a number of things. So we can use it just as easily for molecules as we can for atoms. Okay, so we can use Avogadro's number as our conversion factor to go between moles and molecules of a compound. So let's suppose that we want to figure out how many water molecules are in a 10-gram sample. Again, assuming that this sample is nothing but pure water. Okay, well, we're given the mass, so we're going to go from the mass of the compound to the moles, using the molar mass of water, which we've already calculated, and then use Avogadro's number to get us to the number of molecules. Okay, so we line this up just like we did before. So we start off with what we're given. So we have 10 grams of water, and there are 18.02 grams of water for every 1 mole of water. And we know that there are 6.02 times 10 to the 23rd molecules of water in every 1 mole. Then we plug this into the calculator. And I wind up with 3.341 times 10 to the 23rd molecules. Okay. And we could also ask a question in the other direction, like, what is the mass of 1.50 times 10 to the 24th molecules of water? Okay, now again, this is just the opposite direction, so we're being given the number of molecules. So from there, we can go to moles. And to do that, we need Avogadro's number. And then to go from moles to mass, we need the molar mass of water. Okay, we set this up similarly, but in reverse. Okay, so we have the number of molecules. Avogadro's number is 6.02 times 10 to the 23rd molecules per mole. And according to the molar mass of water, we have 18.02 grams of water for every 1 mole. And again, this goes in the calculator. And I wind up with 44.9 grams of water. Okay? Now there's an additional step that we can take here and actually get even more information. Okay, so we already know that we can go from the moles of an element to the atoms of an element. And we can also go from the moles of an element to the mass of that element. We know that we can go from moles of a compound to molecules of a compound. And we know that we can go from moles of a compound to the mass of the compound. Okay, and of course, to go between mass and moles, we need the molar mass in either case. And to go between moles and atoms or moles and molecules, again, we need Avogadro's number in either case. But we know that there are atoms in molecules. So if I were to know the mass of a compound, and I wanted to figure out the atoms of a particular element in that compound, how would we go about doing that? Well, we would need to be able to link together these two things, which is exactly what we're going to do here. Okay, so here you can see that we can link the moles of the element to the moles of a compound via the chemical formula. Okay, we'll talk more about that in the next chapter actually, but the chemical formula tells us the number of atoms of each element present in a particular molecule. Okay, so if you consider water, for example, okay, we know that in a molecule of water, okay, there are going to be 2 hydrogen atoms for every 1 water molecule. Okay, another way of looking at that is that for every one molecule of water, I'm sorry, not one molecule, but every 1 mole of water molecules, there's going to be 2 moles of hydrogen atoms. Okay, and again, we get that from our chemical formula. So let's say we want to know how many hydrogen atoms are in 3 grams of water. Okay, so we're going to be going from the mass of water, and we're hoping to wind up with the atoms of a particular element. Okay, so we need to go from the mass of the compound to the moles of the compound, using the molar mass of water as our conversion factor. Go from moles of compound to moles of element, and then from moles of element to atoms of that element. Okay, so we have the mass of H2O. We're going to use the molar mass of water to wind up at the moles of water. And then we can use the chemical formula to go from the moles of water to the moles of hydrogen. And then to go from moles of hydrogen to the atoms of hydrogen, we need Avogadro's number. Okay, so let's set this up. We have 3 grams of water. Okay, and in this calculation, I'm going to be careful about keeping water in H in the units because sometimes things can get a little bit cross-wired here. Okay, so we have 3 grams of water. We know that the molar mass of water is 18.02, so there are 18.02 grams of water for every 1 mole of water. Okay, and we know that for every 1 mole of water, we have 2 moles of hydrogen atoms. And we know for every 1 mole of hydrogen atoms, we have 6.02 times 10 to the 23rd hydrogen atoms. So you can see here why I kept the identities of the elements in the units, because we want to make sure that when we get to this stage right here, that we have the right thing on the right side of the line there. Okay, so we're going from water to hydrogen, so we want to make sure the hydrogen's on the top, water's on the bottom. And just like before, we can plug this into our calculator. Okay, and I wind up with 2.00 times 10 to the 23rd hydrogen atoms. Okay, so again, we have a very valuable tool here. Being able to relate masses to number of atoms is going to be something that's very useful to us in future chapters as well.